Okay, sure. Uh, so last time, Shabab, we started solving a problem on the evaluating work and heat. Okay. So in this problem, Shabab, we have water going through two processes. And just quick summary about the problem from last time. The initial state of this water is superheated vapor at 10 bar and 400 degrees Celsius. It goes through process 1 to 2, which is a cooling at constant pressure. So it's compressed at constant pressure while it is cooling until the second state, which is the saturated vapor state. Then from state 2 to 3, this is the second process, is we continue cooling the water but at a constant volume until the final temperature becomes 150 degrees Celsius. Alright? So the question is now, plot the TV and PV diagrams, evaluate the work done in kilojoule per kilogram, and evaluate the heat transfer in kilojoule per kilograms. Okay? So this is the question. Last time we started with part A, Shabab, and we said in order to plot, this is always the case, Shabab, in order to plot the TV and PV diagrams, you need to know exactly each state, what is the phase, what is the properties at this state. Okay, so basically you need to define the phase of each state, and how can you do that? You need two independent properties. So you need to analyze each state, you need to look at each two independent properties and what is the phase corresponding to that state. Alright, so this is what we did last time. We started with state 1 at P1 and T1. We saw that at 10 bar and 400 degrees Celsius, this is superheated vapor. Also at state 2, we know that state 1 is process 1 to 2 is a constant pressure process or isobaric process. So we are going to be on the same pressure line for state 2. And then T2 is simply the saturation temperature at 10 bar, since this is a saturated vapor state. And V2, okay, we need to evaluate V2 because V3 is equal to V2. Alright, so V3 is a constant, so process 2 to 3 is a constant volume process. So the specific volume at the third state is same as the specific volume at the second state, however at different temperature, which is 150 degrees Celsius. If we look at this temperature in the temperature table and compare the V or the specific volume at state 3, you will see that it is a saturated mixture state. Okay, so in this case we know each phase and for each state. خلاص احنا عرفنا الحين how many temperatures do we have, how many pressures do we have, how many volumes do we have, and then we can simply plot the processes and the states on the TV and PV diagram as we did last time. في أي سؤال على ال TV PV diagram؟ Any question here? Okay, so if you can see in the TV diagram, from 1 to 2 is a constant pressure, so I'm gonna walk through the constant pressure line from state 1, which is superheated vapor, to state 2, which is saturated vapor. From process 2 to 3 is a constant volume process, so I'll go vertically down until the lower pressure, which is at the saturated mixture state at the state 3. Okay. For the PV diagram, since I have three temperatures, I have three constant temperature line, and then I start from state 1 as superheated vapor, and then goes horizontally for a constant pressure until state 2, which is saturated vapor, and then vertically down to a saturated mixture state at T3. Okay, so this is the TV and PV diagram, and you should know how to actually plot this TV and PV diagram. طيب, the second part of the question now is to evaluate the work done or the specific work in kilojoule per kilogram. وش تتوقعون يا شباب? How can we proceed? How can you find the work?
I'm using the first law of thermodynamics.
For the work done?
Yeah, the total change in the energy of the system is equal to Q minus W.
طيب. طيب السؤال انه انا ما عندي الكيو هنا وما عندي الدبليو. So how can we evaluate it?
integration of B over V.
ايش قلت؟ اللي هو ايه؟
integration of B over V.
ايش فيكم يا عيال تألفون في
أقصد إن integration BV B dV.
يس بي دي بي يعني المفروض ما تخربطون خلاص واضحة. So integral of P dV. طيب الحين أنا عندي two processes. How can I do that? How can I evaluate P dV?
نحسب كل بروسيس لحال.
You do it each process individually.
ممتاز. يعني I can write ايش؟ I can write 1 to 2 P dV plus 2 to 3 P dV. طيب البروسيس الأول is constant pressure. البروسيس الثاني is a constant volume. وش تتوقعون الفاليوز حقت ال constant volume process؟
It's going to be 0
ليش؟
because we are integrating from the same value.
So there is no change in the volume, so the dV is 0, so this is 0. Okay? This is actually correct. So if we look at here, we see that W is integral for the first process plus the integral for the second process, and the second process, as we said, is 0, so we end up with the first process. And since the first process is a constant pressure process, what is the integral equals to? We see that P is simply V2 minus, it's going to be P, which is constant, goes outside, then becomes V2 minus V1. In terms of specific work, so capital V here is M small v, so I can divide by M, so it will be, this is my specific work, which is P small v2 minus small v1. Alright? خلاص احنا ايش نحتاج الحين؟ عندي ال P for the P1 or P2, it's gonna be 10 bar, so I have P, and I need V2 and I need V1. If we go to our cases here, I know what's V2, and same thing, I can find V1 from table, the superheated table at 10 bar and 400 degrees Celsius, and it will be 0.3066. Okay, خلاص, you plug numbers, 10 bar, 10 to times 10 to the power 5 to get it to Pascal. You have V2 here, 0.1944 minus 0.3066. You will find the answer equals to minus 112.25 times 10 to the 3 joule per kilogram, or we can change it to kilojoule per kilogram. إيش يعني negative work here? That means إيش? This is it work done on the system or by the system?
By the system.
By the system, are you sure? احنا وش كنا قاعدين نسوي هنا؟ We are cooling, so we are compressing, and we said this is compressed at a constant pressure. That means what are we doing here?
It's work done on the system.
The work is done on the system, and our convention is the positive work is done by the system, negative is done on the system. So this agrees with our convention, so, and with our problem, since we are compressing the water as we cool it, So this is work, the negative work, which means it's work done on the system, which is correct. So our solution must be correct. أي سؤال هنا على الwork done? Any question about this? Any question about this يا شباب؟ واضح؟ واضح how we evaluated the work for multiple processes. لو كان عندي process 3 to 4, 5 4 to 5, whatever, you can just add that if you have expansion or compression. Okay. Okay, excellent. So let's go next to the second problem, which is now the last one is evaluate the heat transfer. So now I have the work. How can I evaluate the heat transfer?
First law of thermodynamics.
So we apply the first law of thermodynamics. So we know the first law is change in kinetic energy, change in potential energy, change in internal energy equal Q minus W. So now I evaluated here W. So I need Q. What are the values here?
Zeros.
So we can neglect potential and kinetic, so there is no information, and most likely they are negligible. So you have the change in internal energy, right? So let's have it here. We can see it here. All right, delta U equals Q minus W. So Q is simply delta U plus W. You can divide by mass. So delta U here is M times small delta U or delta small u. So you can divide everything by M. You end up with Q over M equals. طبعا I wanted to actually ask you about this. What do you think the change in internal energy here for the whole process? For the change of internal energy يا شباب, يعني if I want to separate it for the two processes, which بتكون? What do you think? So for the first process we have U2 minus U1 صح? Plus U3 minus U2. فلو تلاحظون عندي هنا plus U2 وهنا في minus U2, so it will cancel. So for the change يا شباب of the process, if you have multiple processes, it doesn't matter the in-between state. So you take the final state minus always the initial state. This is for the change in internal energy. Okay? يعني الانترنال energy ممكن تزيد ممكن تنقص ممكن whatever, but it reaches a final state. So the change in internal energy is simply the final state minus the initial state. هذه واضحة يا شباب؟ Okay? So delta U here is simply U3 minus U1. Directly, and you don't need to go through U3 minus U2 plus U2 minus U1, so U2 will cancel. Okay, so it's U3 minus U1. وضحت هذا يا شباب؟ Is this clear?
Clear.
طيب السؤال الحين, how can I evaluate U1 and U3?
Using the tables.
ممتاز. So U1 we know is superheated vapor, so we can simply go to the table A4 at 10 bar and 400 degrees Celsius. We can find U1. Okay, and this is relatively easy. What about U3? شباب, how can I evaluate U3? Any idea?
using the X.
أيوة. So U3 state 3 is what? State 3 is saturated mixture, صح? So this is saturated mixture. Okay. So for a saturated mixture, you know that any properties I can use the quality to evaluate the property حقت المixture. مظبوط؟ معي يا شباب؟
Yes.
So this is here. State 3, I have U3 equal UF at third state equal plus X times UG at third state minus UF at third state. طيب كيف عندنا quality ولا ما عندنا؟ Do we have the quality or not?
We have temperatures, we have pressure, so we can find it.
احنا عندنا temperature. اوكي طيب يعني انت قصدك انه ما عندي X. You need to evaluate the X or find the X صح؟
Yes, exactly.
Okay, so what is the procedure to evaluate the X?
You're using the specific volume.
ايوه احنا ايش عندنا هنا في state 3؟ عندي ال specific volume عندي U3. ف at the same temperature هذه عندك V3 وعندك VF وعندك VG. So you can simply find the quality. Okay. لأنه ال V3 هذه هي حقت الميكتشر أصلا أساسا يعني. Okay. So simply we can do like this. So X3 is equal to V3 minus VF at state 3 over VG at state 3 minus VF at state 3. So this is evaluated at 150 degrees Celsius. You find that the quality is around 0.5. So it's around 50% vapor. So evaluated X. Now again at 150 degrees, I can find UF and UG and evaluate U3 in this case. So I give you here the final answer على طول. So you find U3 as 1583.8 kilojoules per kilogram. This is يا شباب the type of problems you can expect to see in the midterm exam or in the also next quiz. يعني we should be having one more quiz before the midterm غير هذا اليوم يعني about chapter 2 اللي هو ال first law evaluating work and heat. It's important to practice that before the midterm inshallah. So I have U1 and I have U3 خلاص I can simply plug in U3 minus U1 plus I have the work already evaluated from the previous part, so I end up with like this. So put all numbers here, you get the final answer to be minus 1486.4 and around this kilojoule per kilogram. You see that the Q here or the heat transfer is negative. That means this is heat transfer into the system or out of the system? يا شباب what's the النيجاتيف معناته ايش؟ معناته it should be out of the system, which agrees with our problem here saying that we are cooling water. Water is cooled, water is cooled. So this is most likely correct. So because we got a negative heat transfer. So that means the heat is indeed transferred out of the system. Okay. Any question before we start the quiz?
Yes, please. Doctor, how did you divide by M on W and Q but not delta U?
عيد سؤالك.
كيف قسمت الماس على الورك والهيت بس يعني مو على الدلتا يو؟
اصلا هي الاساس مضروبة في الدلتا يو. الكابيتال دلتا يو عبارة عن ايش؟ ام سمول دلتا يو.
صح.
فهمت؟ يعني انا اخترتها على طول.
يب.
طيب
اوكي.
دكتور، الحالة الأخيرة ضربت الجواب بالإم ولا خليتها كذا؟
الام انا ما هي عندي، عشان كذا قلت السؤال اصلا يقول لك find it per unit mass، يعني per kilogram.
أوكي.
That's why the unit is kilojoule per kilogram. This is specific heat transfer and this is specific work.
مهم.
Okay. يعني in other words, what I am solving here, I'm using small q equal delta u plus small w. Okay. So this is the same thing, similar to internal energy, similar to volume. If I divide heat will work by mass, I get what? I get specific values. Okay, so I can either write it in this form or write it in this form, اللي هو Q equals small delta U أو delta small U. Okay, لكن احنا عشان نفهم أساسها جاية من وين؟ جاية من هنا اللي هو M small delta U plus W. If you divide by M everywhere, so this cancels, so you get Q over M equals delta U plus W over M. This is the specific work and this is the specific heat transfer. Okay. أي سؤال ثاني؟ Any other question? طيب يا شباب. So please start setting your camera and open your camera please, so that I can make the test available to you. You have 20 minutes. Okay, once we start the quiz, you have 20 minutes and 5 minutes to upload your problem. الابلود it will be in the same test يعني. Okay. So please يا شباب يلا.
دكتور عشان نسوي نحتاج الكاميرا، فكيف حيكون النظام؟ هنحتاج الجوال أصلاً يعني.
Yes, you can use your phone. يلا يا شباب everyone، عشان لا نتأخر بس على اللي عندهم كلاسات.